Hello seekers. Welcome back to the channel The GANN Way. This video will be part of the series of true GANN geometry. I mean, many have a very wrong idea of geometry when it comes to the GANN field. So I thought, why not show you guys the real deal? The true geometry at work. For that I want to draw your attention towards some basic things which are must for working out with advanced stuff. First we have, which many are familiar with, is the Fibonacci series. The Fibonacci sequence, also known as Fibonacci numbers, is defined as the sequence of numbers in which each number in the sequence is equal to the sum of two numbers before it. Fibonacci sequence equals 0, 1, 1, 2, 3, 5, 8, 13, 21 and so on. Here, the third term 1 is obtained by adding the first and second term. That is 0 plus 1 equals 1 similarly. 2 is obtained by adding the second and third term, 1 plus 1 equals 2. 3 is obtained by adding the third and fourth term, 1 plus 2, and so on. For example, the next term after 21 can be found by adding 13 and 21. Therefore, the next term in the sequence is 34. The Fibonacci sequence is closely related to the value of the golden ratio. We know that the golden ratio value is approximately equal to 1.618034. It is denoted by the symbol phi. If we take the ratio of two successive Fibonacci numbers, the ratio is close to the golden ratio. For example, 3 and 5 are the two successive Fibonacci numbers. The ratio of 5 and 3 is 5 divided by 3, which is equal to 1.6666. Take another pair of numbers, say 21 and 34, the ratio of 34 and 21 is 34 divided by 21 equals 1.619. It means that if the pair of Fibonacci numbers are of bigger value, then the ratio is very close to the golden ratio. Let's start with the Fibonacci spiral. We need to use Vesica Piscis for the same. The Vesica Piscis is a type of lens, a mathematical shape formed by the intersection of two disks with the same radius, intersecting in such a way that the center of each disk lies on the perimeter of the other. We'll be using the Vesica as the basic unit, but using it to create firstly the 2:3 ratio. For this to create firstly the 2:3 ratio, and the rectangle in there which is full of some very interesting information, but also then you also firstly will be using it to create a perfect phi ratio, and then using it to build a Fibonacci spiral. The Fibonacci numbers being 1, 1, 2, 3, 5, but we have 2:3 ratio built in there, and so there's a few different ways to get firstly the perfect phi ratio. And the more you develop the spiral, the closer of a ratio gets to perfect phi. But it's on a wave, and that's a complex being on its own, but so firstly we'll be using the Vesica and creating a perfect phi ratio. Okay, so we have these 3:2 phi ratio. I'll just divide it up into sections 1, 2, 3 wide and 2 across, but we can now get phi ratio directly from here. Now what really is important is that what is the diagonals of these squares. As we can see, that first square is with two sides 1 and 1, so by using Pythagorean theorem, we will get the third side of the triangle, which in fact is a diagonal of the square. So 1 square plus 1 square equals to 2, and the diagonal will be equal to root 2. You can calculate yourself other diagonals, but what really important is root 2 and root 5. What is the value of root 2 and root 5? I will leave that for you. Goodbye.